Number 8. First thing I notice is that neither of the inequalities is in slope-intercept form. So that's where I want to start. I want to put them both in slope-intercept form. The first one is 3x plus 2y is greater than or equal to negative 2. It did it again. Puts that thin line in there for some reason. I have to be hitting something. Okay, so I want to put this in slope-intercept form. That means that I need to solve for y. So I'll move the 3x and cancel. So I'm left with 2y is greater than or equal to negative 3x minus 2. And then I'll divide by a 2. Now, if that were a negative 2, I would have to reverse that sign, but it isn't, so stays the same sign. I'm going to break this into common denominator. So I will have y is greater than or equal to negative 3 halves x, there's slope, minus 1. So there is the y-intercept, and we have slope. So at negative 1, I can start going down the stairs. I would go down 3 and over 2. So the point would be right there. And by the same token, I can reverse that and get this stair step. I can even get one more on this graph. So here's the pattern of down 3 over 2, down 3 over 2, down 3 over 2. You're going down the stairs, and you want to connect the dots. And this line is solid, so that looks pretty good. And we want to shade everything above that line. This is greater than, so anything above the red line gets shaded. It could even be on the red line because you do have an equal sign. So if that first inequality were all I had, there would be the graph. But we have another boundary that's given by the blue line that I'm about to draw. And we have x plus 2y is less than or equal to 2. And we want to solve this one for y as well. So let's move the x and cancel. So I'm left with 2y negative 1x plus 2. And then I want to divide by 2. As long as it's positive, you don't have to reverse the sign. So I'm left with negative 1/2 x plus 2 over 2, or negative 1/2 x plus 1. The y-intercept is at positive 1. And I'm going downstairs again. Okay, guys, this is driving me crazy. That stuff coming up there. So at that point, I will drop 1 and go over 2. Drop 1, go over 2. Drop 1, go over 2. And you can almost see that region getting carved out there. I do think I'm going to go one up here to this point, just to make sure I see the clear boundary. Okay, so here is the line that I need to draw in. It's negative slope on both of them, so they should both be going downstairs. And you can see where I need to carve out my region. It has to be below the blue line and above the red line. So below the blue line, we'll take out all of this. Below the blue line, above the red line. So the region is right in here, and I do need to include that part too. It's a little bit hard to get it exact with this pen, but let's try it this way. There we go. The region is between the lines. Now, I do want to show you on this last problem how you can check this to be sure that you have the right solution, the right region. Pick a point in the yellow area, and I'm going to pick 0, 0 because that's the easiest one to do. The origin is in there, so let's test with origin. You want to go back up here and get these two inequalities. We're going to test them both. They both have to be true, or we've done something wrong. So I have 3x plus 2y is greater than or equal to negative 2. And I'm testing 0, 0. So 0 plus 0 is greater than or equal to negative 2. That is a true statement. That's a good sign. Then x plus 2y is less than or equal to 2. So 0 plus 2 times 0 is less than or equal to 2. 0 is less than or equal to 2. That is true. So that tells me that the region is correct. You can always check by substitution if you are so inclined. And I believe that's the last. Oh, there are the answers. So you've got those if you want to look at those. But hopefully now you understand how we got those answers. These are good problems, and I've enjoyed this. It's been a long time since I've thought about these.